Example 2. We have the function f of x is equal to x cubed plus e to the x. And we're asked to find the value of f dash inverse of f at x equals 1. And we're also told that the point 1, 0 lies on the inverse of x. So this last piece of information will save us a lot of time and effort, because it means if 1 is the x coordinate, 0 would be your y coordinate. X in the domain, if we put 1 in, we get 0 out. So it means that if x is 1, the inverse of 1 is 0. So we can use this property. If you put x equals 1 into the function, 0 will come out. So it's the y value here that's 0, and this is what we can use to make this a little bit simpler. Inverse function of 1 equals 0. So we're evaluating. Go back to the original function f of x, x cubed, add e to the x, and take the derivative. F dash x equals 3x squared plus e to the x. The inverse derivative, using the formula, is 1 over f dashed inverse of x. This part of the equation, the inverse of x, we've already evaluated that. We know that the inverse of x when x is 1 equals 0. So this part that I've circled actually equals 0. The derivative of the inverse of x equals 1 over f dashed inverse x of 1. So it's 1 over f dashed of 0. So we're putting the derivative here, and the derivative was 3x squared plus e to the x. So it's just a matter of substituting 0 into f dashed. 1 over 3 times 0 plus e to the 0. E to the 0 equals 1, so this all equals 1 over 0 plus 1, so that's 1. So that's 1. Example 3. F of x equals 1 subtract 4x cubed, and we're going to find the value when we take the derivative of the inverse function when x equals 5. So I'll start by looking at the formula and deciding a plan on what to do. The derivative of the inverse function is always 1 over f dashed inverse of x. So this means I'm going to need the inverse function and the derivative of the original function. The original function was 1 subtract 4x cubed. Take the derivative, that's negative 12x squared. Now to work on the inverse function. The original was f of x equals 1 subtract 4x cubed. So we replace f of x by y, 1 subtract 4x cubed. Swap the x's and y's and transpose for y. X subtract 1 equals negative 4y cubed. We'll multiply through by negative 1. Negative x add 1 equals 4y cubed. So I can change the order of the left hand side to 1 subtract x equals 4y cubed. Divide by 4 equals y cubed. Take the cubed root, 1 subtract x over 4 equals y, and just rewrite this with the inverse function notation. Inverse of x equals, that's the cubed root, 1 subtract x over 4. Inverse function of x is the cubed root of 1 subtract x over 4. And we need to know the inverse when x is 5. So put x equals 5 through this equation. 1 subtract 5 divided by 4. So that's the cubed root of negative 4 over 4. Cubed root of negative 1. It is possible to take the cubed root of a negative. It's also negative. Negative 1. So we follow back to our formula for the derivative of the inverse function. 1 over f dashed inverse of x. This time we're working out what this value is when x is 5. So evaluating these is slightly easier than actually working out the formula. This means we replace x by 5. Now in brackets, this part we already know from the previous slide. We know that the inverse function of 5 is negative 1. So we can substitute the value of negative 1 into the derivative. Inverse function of 5 equals negative 1. And the derivative, remember the derivative of the original function was negative 12x squared. So if we do derivative of negative 1, negative 12 times 1, negative 1 all squared. Negative 1 all squared is 1, so negative 12 times 1 is negative 12. So we're just putting the negative 12 on the denominator, 1 over negative 12. So that's our answer. Example 4. we have f of x equals x plus 4 over x subtract 2. Again, we need the derivative of the original function, which we'll have to do using the quotient rule. Quotient rule, we take the derivative of the numerator, 1, multiply by the denominator left alone, subtract the numerator multiplied by the denominator differentiated, which is 1. Divide by x subtract 2 all squared. Tidy up the numerator, x subtract 2, subtract x, subtract 4 over x subtract 2 all squared. The x's cancel and we have negative 6 divided by x subtract 2 all squared. We'll need this later. Our original function is x plus 4 over x subtract 2. And we need to work out the value of the inverse function when x is 3. Now, we can find the inverse function of f of x algebraically, but this is actually not necessary. There's another way that we can do it. In this function, inside the brackets, x is equal to 3. So that means the domain of the inverse involves the number 3 over here. Going backwards, we'll get a number out. So we don't know this number. The inverse function of 3 equals don't know. This is a diagram showing the operation of the inverse function. From one of the other videos, we know that operating the opposite way is the original function. So in the original function, the values in were the x's and the values out were the y's. So this means if we have the x equals 3 going into the inverse, that 3 represents a y value in the original. So in the inverse function, x is 3. In the usual function, the normal function, that means y is 3, or f of x equals 3. So we can actually substitute f of x equals 3 and work out x. So we put 3 here, x plus 4 over x subtract 2, and calculate x. 3 bracket x subtract 2 multiplies to remove the fractions. 3x subtract 6 equals x plus 4. Collect the x's on the left. 2x subtract 6 equals 4. So 2x equals 10 and x equals 5. Finally, we have our answer, that the inverse function of 3 equal to 5. Inverse function of 3 equals 5. So I'll just go over how we got that. We put y equals 3, or fx equals 3 into the original. And that was to find the x that goes into original. So finding the x that goes into the original is the y from the inverse function here. The formula for differentiating the inverse function is 1 over f dashed inverse function 3. That's just replacing the x's with 3. So we now know inverse function of 3 is actually 5. Place that here, f dashed of 5. So we just need to evaluate f dashed of 5. F dashed of x, negative 6 over bracket x subtract 2 all squared. So f dashed of 5 equals negative 6, 5 subtract 2 all squared, negative 6 over 3 squared, negative 6 over 9, which is negative 2/3. Finally, our formula shows us that we must put 1 over f dashed of 5. So that means 1 over the value of f dashed of 5, which we got from the previous slide. F dashed of 5 is negative 2/3. Negative 2/3 goes on the denominator. Dividing fractions, we take the denominator, flip upside down. Overall negative, 2/3 upside down, its reciprocal is 3 over 2, and that's our final answer.